here. Okay. Great. I usually, who doesn't understand anything from English, because we have people from outside, so I will try to speak my best English, but I don't native English, so I will try to do my best. Thank you for coming. Thank you, everybody, for staying here. There's a lot of things that we do as a usual group. We are people already engaged in a lot of things, and we like to share the knowledge like we do today. So thank you very much for coming. And I'll only show you what we do. I don't only the only one. Who we are? Well, we are like a group of people interested in technology, and we are always open to understanding technology, to discuss about technology, play about it, and share our knowledge and experience about it. And yes, we are people really interested about new things, new material, new kind of databases like Neo4j. So that's who we are. And what we do, it's today is a typical day. I mean, it's a typical event. What we do is like a magister class or speak about kind of technology. We always try to bring good speakers like today we have, but we also discuss about new technology. We would like to start to move in the direction and build some kind of open source project and contribute to the community. So we are trying to keep the community growing and growing, and well, we are trying to bring a lot of energies in this community and bring all the developers space to contribute to something and share our experience and build something great. Okay? So if you want to have an idea and you want to share something, go ahead. What we're looking at is really easy to understand if you know who we are, what we're doing. So we are looking at people top of mind kind of vision of what is the technology, what kind of technology is really interesting, and what kind of new places we can go around. We're also looking for great speakers and even contributors to the community, and why not as sponsors. Okay? We are doing this for free for you, so if you have kind of company that would like to sponsor the community, we are already open for this. So we have a lot of few links, so if you are new, I'm not sure how you arrived here, but we have few social networks that are working really fine, like Google Plus or Twitter, but also we have our main page, it's like a blog site, and then the last one is the meetup that is growing week by week. We have about 120 people right now, so we have 180, I think, in Google Plus. So if you want to stay connected and know something and share something, we have a lot of channels that you can use one and then bring something into the class. So please use the hashtag if you want, mention us, it's free if you want. So what we're doing today, you know, because we're here, but what we're doing the next day is about the 10th of December. We are moving to a workshop, more like a hands-on project, and then play with two frameworks like a JVM and rooms, runtime, a framework for developing runtime rules and executing. So Mauricio, you don't know, Mauricio is one of the best contributors to JVM and is working in Red Hat. So it's a nice guy, he's a really good speaker, and I think you will likely want to attend to this day. A really interesting workshop. And we have a lot of things that we want to share with us and with you, like technology, like the cloud. We talk about Amazon Web Services the last month, I think. We have a lot of new ideas about working with Amazon and playing with the cloud, and well, we have a lot of ideas that we would like to share with you. And please tell us what do you prefer. So we have another one like Balin, another framework for fast developing websites. Another one about Guava, the framework from Google, and a lot of more ideas about what kind of framework the people is working with and what kind of framework people like to play with. But please share with us what do you prefer and what do you like to move on. So it's up to you. And I think it's enough. I mean, that's your point. Okay, so say hi. Welcome to BarcelonaJUG, please, and join us and share your experience and contribute to the community. So, for raising up today, I would like to thank to Stefan and Dean from Neotechnology, and I think they will share their knowledge with Neo4j, this graph database, and I think we would like to understand how Neo4j works and what represents the graph database. So thank you very much for coming and welcome. Yeah.
So thank you very much for a nice introduction. Give me some second for Jane.
Hello, good evening. As already introduced, my name is Stefan. I work for Neotechnology, which is the commercial backing of the open source graph database Neo4j. Please excuse the bad quality of the slides. It's not that you're drunken. The shadow, it's because there is a crappy wire in the wall. So, I will provide the slides afterwards. So. I think if you cannot read something, please ask me. Also, if you have questions during the talk, please ask. So I'd like to have this more discussion-like thing. I have a couple of slides, and afterwards I plan to have some live demo, and we can go as long as you want. If you're annoyed and say, okay, stop with that shit, tell me as well, so we can avoid it any time. So here you have my Twitter handle. It's Darth42. There's my email address. I want to thank Michael Hoover and Jim Weber because I stole most of the slides from these guys. I'm lazy. These guys make great slides, so why not use it? I have 5 books with me. They're called graph databases, and I want to raffle them. So we create a list. Please write your name, your email address, and if you want a company name. And then at the end we go on random org and choose by index, look at which one gets the book. For all those who didn't get the paper version, this one is available as PDF for free on graphdatabases.com. Okay, let's get started. So normally on this slide we have the word agenda, but in a graph code we call this a path, right? We're first looking at this nasty buzzword called NoSQL. So before getting into detail, who of you has already used a non-relational database for something? Okay, well, that's almost a half. Cool. Which of you have one in production? Okay, that's 3 people. Who of you has used a graph database? 1, okay. 2, oh, cool. Okay, in production anyone? No. Okay, fair enough. So that's a pretty common ratio for user groups. So I have given talks in a lot of cities now. Recently, a lot of German ones. Germany is more not that much keen on new technology these days. So Java developers are more enterprisey and EGP based, and but that's a pretty good ratio here compared to other cities. Cool. Okay, first we want to set a little bit the landscape for what NoSQL means to us, and to try to understand why there are different data stores. Then we want to look at especially at graphs, why graphs are important, why we should use them. When we motivated the word graph, we want to look at what makes a graph database. And afterwards, some things about Neo4j. Neo4j is, in our opinion, the world-leading graph database. And if you look on Google Trends or something like that, you will see we're basically the market leader there. I forgot to introduce. I have my colleague Dirk with me, so he's our sales director for Europe. So if you have any commercially related question, hammer him. For tech stuff, it's me.
I'm out.
What?
I'm out.
You're out? Oh no. And at the end of the slideshow, I have some, because graph databases are pretty new concept, you wonder where people can use that. So I have a couple of documented use case from real-world projects. I just want to give you an idea on how you can use that and what the thing is about. Okay, so we recently, in the last, let's say last 8, something like this, 8 to 5 years, we saw some changes in the way we deal with data. There was the trend number one that we see is that the pure amount of data increases a lot. So there was this quote from Eric Schmidt from Google. He said, and this quote is from 2011. He said, in 2 days in 2011, they handled the same amount of data they did the whole year of 2003. So there was a chart, and this is really exponential growth of the pure amount of data. The second trend is that the data gets more and more connected to each other. So think of the old days. Anyone in the room who still knows what offer was? Offer? Anyone? Oh, cool. Yeah, this was the old before the web was invented. I still use that. This tells me I'm getting old. Okay, so this was just kind of loosely linked documents. Then we had the classic web 2.1 thing where we had just some connected web pages. Then some interactive stuff was added. We had some blogs where you can put comments. The users were supposed to generate a lot of comments and material. So the thing gets more and more connected, and now these days we're going to something like semantic web, where we have really the metadata that makes the connections on the internet directly. So the data gets more and more connected. The third trend we have is that the data gets less and less structured. Just as a very simple example, so back in the old days, if you graduated as an engineer in Germany in the 70s, what you do is you go to Siemens, sign up for a job, and 5 years later you retire, and you just spend the whole life with Siemens or some other large-scale company. These days life is different. So you study something, then you join a startup, then for a couple of period of time you don't have a job, then you sign up for 2 jobs at once, stuff like that. So it doesn't fit in a single schema anymore. So data gets less structured. The fourth trend we see is a switching architecture. So in the old days we tried to have a single database, and there was first one application communicating with one database. Then people thought, okay, that's cool, we want to use the database more, and they created a second application speaking to the same database. There was a couple of more applications were added, and the database was basically a kind of integration layer. These were times when we wrote a lot of PL/SQL stored procedures to make our applications work. Anyone familiar with this PSQL stuff? Yeah. Anyone in the room who likes that? Okay. Based on the experiences, because this stuff is hard to maintain, there was a shift to create separate service for separate purposes. So we have a rather small database with a service on top of that. We have another database with another service on top. And above that construct, we have a kind of integration layer, which people call then service-oriented architecture or something like that. So it was more composing of, a big thing was composed of multiple smaller things. And that also offers a lot of more ways to scale things out. So these days, when you have a shopping application, you want to scale the beast. Because if you're running now close to Christmas, you need a lot of more bandwidth than you need the rest of the year typically. And that's not possible with monolithic approaches. Therefore, you need this separated and distributed approaches. Okay, these trends basically led to new buzzword, or it's not that new anymore, it's the NoSQL buzzword. It does not mean, we're not saying no to SQL. SQL is still good enough for a lot of use cases. But we recognize there are use cases where SQL is probably not the right choice. We're also saying never SQL. Well, there are cases where we don't want to deal with SQL, but it's not, we don't want to throw it out of the window now. But it means basically not only SQL. There is a formal definition for that. You can read through that. It's from Wikipedia. I don't want to read that out now. But in my opinion, NoSQL basically means think about your data. So look at the problem you have, look at the structure of the data, and think about that. And then choose the right tool in your box. If your toolbox just has a hammer, obviously anything looks like a nail, and you just hit your relational hammer on any problem. My sister's son plays with a box like that, and that guy has learned pretty fast. Well, the blue piece just goes through that thing, and so he needs to choose the right tool for the right problem, and that's the same with NoSQL. So we need to think about it. The problem is, in our industry, we're using for roughly 25 years relational databases, and we're so used to it. So it's totally natural to us that for any kind of problem, we throw it through our ER modulation machine, throw it on, and squeeze it and crash it to get some tables out of it. So, who of you has ever had an SQL statement with more than, let's say, 5 joins? Yeah. Who has to read that statement 6 months after? And who understood that statement afterwards? Right, so there are cases where SQL basically is annoying to us because it's too complex, not readable. So we have sometimes the feeling that we don't want to have them all the time. And then people invented new type of data stores. Typically, these NoSQL data stores are grouped in a couple of categories. But a lot of these implementations cannot be restricted to a single category. So they mostly get started in one and then they expand their scope to other categories. But just as a kind of rough categorization scheme, let's go through that. So first thing, type of data stores are key value stores, as indicated by the last picture. So the key value stores like React, like Redis, they basically map a key to something. The something is the value, and typically the data store has no insight in that something, so it's open to the data store. So it's more or less like a Java util map, but a large one, and it's typically distributed over a lot of machines. So the nice thing about these data stores is you can super easily scale them because the key value pairs are totally dependent. There is no relationship between them. That makes it so easy to scale these kind of things. The second kind of data stores are the column stores, as indicated here with the columns. Right? The column stores are somehow similar to key value, but they map a key to a column family. So there is some insight in the value made out of column families, super column families, and other stuff like that. There is most prominently these days HBase, stuff like that going on. And these data stores are also pretty scalable. But do you know which one is the most scalable column store in the world? Is it Cassandra? Is it HBase? Well, that one here. I stole the joke from a British colleague of mine, Jim Weber, and he says, well, that's the British Museum, and he's a Brit. And he says, every time In the old days when the Brits acquired a new colony, they went there, they robbed all the fancy stuff there, brought it home to Britain, and they need to put it somewhere. Well, there's the British Museum, let's build a new wing and put stuff in. And they scaled this for 500 years. Okay. The next category I want to talk about is the document stores. Most prominently these days by Mongo or Couch. Not sure if you know this guy. There is a video on YouTube. It's just on YouTube, type Mongo and web scale. And look at the video. It's not about that we're blaming Mongo for anything. It's about two people discussing scaling issues. And the one thing who asked the question has no single clue what he's talking about. He's just using a lot of buzzwords in a ridiculous way. And the other one is friendly at the first part, tries to answer that, and at the end he says, oh no, I'm ashamed of being in the same industry as you. I go out and I'm a farmer now, or something like that. So that's one of the best videos on document stores, or web scale. Document stores basically are also a kind of, they have a key for each entry, and they map the key to a document. A document is a tree-like structure, typically a JSON document, something like that. And the document databases provide a lot of indexing over these documents, and you can easily search for them. But they also imply a map that you need to find the key and the structure at the time you save it. So you have to aggregate your data. And this is the same for key value, for the column stores, or for the document databases. They are all assembled under the label aggregate-oriented data stores. This term goes back to Martin Fowler, you probably know him, very famous writer, speaker. And there he says, you need to apply, you need to assume aggregation at the time you write the data. But when you want to read your data, you might have a different perspective. So you need to look at it from a different view of that. And since you no longer can use this, the key structure you have to do a lot of MapReduce to filter and find the data you're looking for. That's why you typically, the aggregate-oriented stores, you typically compute your result, whereas in the relational mode, you query your result. Yeah, that's roughly the landscape I tried to sketch. So we have key value stores, we have columns, we have documents. The graphs is what I want to speak today. And there's also relational, but I think I don't need to mention that part. So when we look at a kind of categorization where we want to draw how much data we can store, so the pure amount of data versus the complexity the data store can handle. We're looking here for key value stores. Well, as said, they're super scalable. They can handle a huge amount of data. So there are a lot of installations of React where they store petabytes, stuff like that. So huge amounts. If you go to the column stores, they can handle a large complexity because there is some insight in development to deal with column families. But the total, the scalability in terms of size is not that big anymore. It goes in the same direction for the document databases. They provide even more insight in the data at the cost of the maximum size. And there are the relational stores. We know them. Relational model is pretty powerful from the data model. You have tables. You can join tables by other tables. You can model a lot of stuff, but you have to make a kind of mapping between what you see in the real world or what you draw on your whiteboard and what you store in the database. That's called this. That's why we call this normalization forms. You will know this from university how this works. On top of that, graph databases. They are from the scaling or from the data size perspective comparable to the relational databases, but they offer an even richer structure, and therefore they're better suited to store complex data. Going to data complexity. So that is basically my opinion, the most important slide of the evening. So the complexity is a function of the size you have to deal with. It's the function of the connectedness and the uniformity. Typically, when people talk about complexity, they only refer to size. But that's just one aspect of it. And there's the second buzzword I have on my slides. It's the last one. It's called big data. And I saw a nice tweet. I just need to put that on the slides. It's too good. Just read through it. Can you read that? Okay. I guess we can continue on that one. So if you typically, when you come from relational world and you try to, for a lot of applications, you reach a point which we call the relational crossroads. So on your way to your application, you come to a crossroad where you have to go left or you have to go right. And this is the point where you have to think, okay, do I want to want to denormalize my data, and I want to go, you could move that one away and say, okay, Sarah, comment it on the cat, and we store the content of the comment in a relationship property, right? That's doable. But we have to think about everything that has an identity on its own should be a node. So the comment, well, we might have a requirement that you want to write answers to comments. So in this case, the comment is a thing on its own, so it should be a node. And this typically changes during your project. So let's make a simple example. So yeah, so since in Spain, well, you have the capital, you have Madrid, you have Barcelona, right? And for simplicity, assume there is a road in between. I guess there are a couple of crappy roads in between, but for simpleness, assume there's a single road in between. So we have the road modeled as a relationship. Perfectly fine for our first release. Then in our next release, we probably want to take into account traffic jams. So for traffic jams, it might be critical if we travel from Barcelona to Madrid or the other way around, because one way we're hit by the traffic jam, the other way around not. So we introduce direction here. So we have two relationships between Barcelona and Madrid in the opposite direction. And then there might be another iteration in our project where we introduce maintenance companies for the roads. So anyone must fix the roads. And there is a big construction company, I'm not sure what's the biggest construction company in Spain for roads, let's say company A for simplicity, and A should now maintain the road, but the node is a relationship. Okay, let's change that, it's easy. So the road that used to be a relationship migrates into a node that represents the road, and the road is connected to the city, and the maintenance company, company A, is also connected to this road. So you can evolve the data model. You can change that very easily, and there is no such thing like alter table. You just delete the relationship and create a new node and connect it as required. But you need to go through these modeling steps. You have to think about it there, and you typically do a lot of discussion with the domain expert on it, which gives you a very good understanding on the core of your problem. So it's also about communication here. Yeah, so that was a kind of graph model our domain expert painted on the wall. And one thing you should keep in mind when coming from relational world. In relational world, we're typically speaking of classes. So we don't speak of Sarah and Adam, we speak of person, photo, and comment. When doing graph modeling, speak of instances. Give the things names. It's more easy to discuss. Especially for people who are like domain experts who are sometimes think different than a software engineer. So draw the thing like it is. And then if you're doing if you're solving the problem in the relational world, you would probably also start with that and then go to your ER modeling software, throw it in, and turn it around until at the end you have a couple of beautiful tables, right? In a graph, it's more simple. You just store it exactly like that in the graph. So that is already a graph, and you store it exactly like that. You might attach labels here, like, well, Lockhart is a photo, Adam is a person as well. Then you need to give the relationships of names, so commented on, likes, friend of, and that's your first graph of your graph model, which you can use for your application. Okay, so let's look at Neo4j now. So we talked about graphs, we talked about graph databases. Now let's look into Neo4j a little bit. So we have a nice slide here where we explain the graph database with a graph. Unfortunately, due to bad wiring, it's hard to read because there are a lot of arrows in between here. So let's make it short. So well, the graph database manages the graphs. We already heard that. Graph records in nodes that are connected by relationships. Both nodes and relationships have properties which are potentially put into index for easy lookup. And then we use a traversal to navigate the graph. The traversal identify paths, and path is kind of ordered list of nodes. That's Neo4j on slide. Yeah. It took me a hard time to learn that. No, there's more complexity there. So, yeah, I already mentioned that. So you can do roughly 1 million per second atomic traversal. Atomic traversal is jumping from one node to a neighbor. That's impossible because both the disk layout of the store structure and the in-memory structure that we use are very efficient in terms of we store things that are close to each other in the graph, close to each other in the memory or in the disk thing. And that sounds really simple, but we have a couple of engineers only working on that. And that's super complex what these guys are doing. I don't have a single clue on that, but I don't have to because it works. And you don't have to mess around with that as well. Of course you can do, it's open source. So Neo4j integrates for indexing, you use Machine under the hoods as index provider, but you can easily exchange that. So you just have to implement one interface, make that transactional, simple thing. You can do this in the afternoon. Neo4j provides ACID transactions. Well, if you're coming from relational world, that's pretty boring because any database in relational world provides ACID transactions. But if you're coming from other non-relational data source, that's a pretty interesting feature because not every non-relational database provides transactions. There are even databases out there which claim to write to memory and then say, okay, I've committed a transaction. When Neo4j commits a transaction, there is a round trip on the file system because a transaction has to be durable. It's your valuable data that is stored there. You don't want to lose data. From a licensing perspective, it's licensed like MySQL and Mongo. So here is Neo4j is completely open source. You can find the complete source code on GitHub. There is one part of the source code or the largest part is the community edition, which provides all the things you need to start with the application. The community edition is licensed as GPL, and there is some enterprise add-ons to that, which are open source, but they are licensed Affero GPL. And if you don't want to comply to Affero, because that basically means you have to open your source code, even if you just use it in the application, you can also have commercial license for that. And that's the reason for being here. So with the commercial license, you typically get enterprise support, and so the additional features in the enterprise edition is the clustering, so you can build up a database cluster, not only a single instance. There is some advanced maintenance, management, and monitoring features. There is a special cache implementation, because, well, in marketing language we call it turbo cache. For you guys in Java world, I can say it's called garbage collection resistant cache. So it's a cache implementation that adopts its size to reduce the probability of a full garbage collection route. And who of you have ever suffered from garbage collection issues? Honestly, only one. Okay, a couple more, good. Okay, so you know what you're speaking about. Okay, there is a cloud offering available for Neo4j. It's running in Heroku. It's currently for free. And there's this is provided by us, and there is our figures. Are they Spanish? Graphene? I guess they're from Spain, right? Graphene is from Spain, right? Yeah, so they're graphenedb.com. They also provide a cloud offering for Neo4j. It's a pretty good product, I like it. It's a pretty smart guy. What's his name? I can't remember that. You probably know him. Right. Neo4j, we should probably remove that because that is going to change it to a 1. So you can store an arbitrary number of nodes there basically. There is in 2.0, there's a limit of 34 billion. If you reach that limit, talk to me, let's discuss modeling. And if after the discussion of modeling with me, I'm still convinced that you have more nodes, I will do a beer. Okay? Pardon?
Only a beer? Only a beer?
A box of beer. A box of nice Bavarian beer. Right. You're looking for use cases. I see. Okay, from deployment perspective, I leave that up to the next slides. And of course, we have high availability in Neo4j Enterprise, which means you can distribute your graph database over multiple machines. And the model is currently a master slave replication. That is nice because a query, any query, can run on any instance independently. So to do a query, to solve a query, you don't have to do any network routers. Any cluster member can handle that completely independently. That's why this architecture scales for read operations mostly linearly. I also need to say, for write operations, you don't get faster by adding new instances to the cluster. You get faster by improving your I/O because we're transactional. So everything has to be written on disk, and that's the particular bottleneck. Okay. Yeah. Schema of recording graph, I think you mentioned that already. Complex data, blah blah blah. That was right. We can jump over that. Yeah. As you see in data modeling, so we just draw our graph on the table and then we store it. So that's probably what we draw on the table. And if you store that graph, and that's now a screenshot from Neo4j 1.9, it looks like that. And that's pretty much the same data if you can read that. So there is no gap between the data and how we store it. There's no mapping in between. You don't have to think about all this foreign primary key, blah, 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 mapping stuff. And deployment, right? So there are basically two ways to run Neo4j. One is you can run Neo4j in embedded mode. Embedded means you are somehow on the Java platform, maybe a Scala thing or maybe a Ruby program or a Java program, and you can just instantiate a Neo4j graph database as a class, and then the graph database comes up. And it's you can directly access the nodes and relationships by Java API. It's available on all these well-known platforms. This embedded mode is very good for testing because you don't depend on a secondary process. And testing with external dependencies always sucks. Or maybe I'm just stupid to handle that. So you have here, your box, and you should see in here the logo of Neo4j. If the project would be different, so that's basically that here what you see here. So Neo4j is embedded in your application, and your client is speaking to that. Let's look at a little bit of code for that. I hope you can read that. Yeah. So, my laser pointer starts to fail. So in here, here we create a new database, new graph database. We give it a path. This is the path of the store files. This is where the binary structures for the graph are stored. And then you accept Neo4j is transactional, so you need to open a transaction. Within that transaction block, you create, on the graph database instance, you create a node, you create another node, And then we set some properties. We have here Steve, we have Michael here, and they did a presentation together in the past. So we create, on the Steve node, we create a relationship to Michael with a presentation, with a special relationship type called presented with. That is something you can always not read here. So that's presented with. On that new relationship, we also set a property with the date when this presentation was given. And then we mark the transaction as success. And then finally we say tx finish to persist the transaction. That's typical Java API usage. And that's called what we refer to the core API, because you do it with very atomic commands like setting properties, creating nodes. So that's the most verbose way to speak with the graph, but also the most efficient way in terms of runtime. There's another nice project which Michael Hummer basically created, was Spring Data Neo4j. So you probably all know JPA or Hibernate, right? So you have your Java domain model, and with Spring Data Neo4j you can use your domain model, and you just throw in a couple of annotations, and these annotations tell the persistence layer how to create nodes and relationships out of that. So in this example, we have here a movie class. The movie class is marked as node entity, which means that thing should be persisted as a node. Within that movie, we have a title. The title property should be indexed. And the movie has a cast and has a director. And for the cast, we declare the relationship type. So that's modeled as an acts-in relationship to direction incoming. So the movie has an incoming relationship from the cast, all the actors who acted in the movie. And then we have the actor that is also known. Is connected to movies, so that's basically the other end of that relationship. And the relationship it's in between is modeled as a relationship entity. So the role class is the relationship between an actor and a movie, and it carries the role name. So which role did that guy play in the movie? So Keanu Reeves played Neo in The Matrix. And that is very nice if you work in an environment where you have existing domain model and you just want to persist it in the graph. But as all these kind of frameworks, they limit, because you cannot do anything with that. Well, a couple of you guys have surely used Hibernate. Who of you have suffered from the n+1 problem in Hibernate? Where you do where first a query is done and then another SQL statement is sent for every result set. So it doesn't handle everything very good. So to benefit from the storage engine, you should not abstract it completely. You should have a way to access it directly. So it's fine to have a Java model for that, but for queries you typically go down to bare metal and execute cipher statements directly on the layer. And for example, if you have a lot of different classes and you need to introduce a new relationship type, you have to change the Java code. If you're operating directly on the graph, you can do this at runtime, so there is no compile cycle involved. So for starting, it's fine. For existing projects where you have already a rich data model, you can use that, probably. But for greenfield projects, think carefully if that is the right approach. For example, if you want to run high volume imports through these classes, that is too much overhead. So there you have to use another tool, or use the graph database directly. Okay. Yeah, the Cypher query language. I will go on that in the demo part a little more. You can run Cypher in the embedded mode as well, which is very beneficial, because Cypher is a very high-level abstraction. So you can have the functionality, let's say 2 lines of Cypher code correspond to, let's say, sometimes 50, 80, 100 lines of Java, plain Java code. And it's much more easy to read and much more easy to maintain. Maybe it runs a little bit slower than the optimized Java code, but expensive these days is not the runtime, because we can just purchase another CPU, but the development hour is expensive. We should stay, and we can do more funny things in our time if we are more efficient here. Yeah, the graph cipher can also be used to modify the graph. So I just shown how but we will have this in the demo part. And there's the other way. We now discussed just working embedded. We can also run Neo4j as in server mode. That is like we are used to work with a database like MySQL. It runs as a separate process, and there is a port where the database listens, and when we send commands to the database, namely SQL commands for relational mode. And in the same way, that thing works in server mode. So it spawns up a process in a separate JVM, and through a REST API, we send cipher statements there to communicate and change the graph. There are some other REST API calls mainly for doing some maintenance and stuff as well. So it's a very rich thing. The big advantage of that is you have your code and the database code in a separate JVM. So if you run into issues in terms of garbage collection, it's very easy to see, is my code the problem guy or is the database the problem? If you have that embedded in the same JVM, well, it's getting challenging. There's also, in the server mode, you can have more flexible deployments. So if your application that uses the database is very CPU intensive, you can scale up that layer independently of the graph database. And if you use embedded in this scenario, for each new instance, you need a new license. So Dirk will be happy about that, of course. But your finance guy probably not. The server can also be flexible. You can run that in-house and manage the thing on your own. You can use cloud managed servers or whatever. So you can separate on servers. So that's mostly the part of the deployment scenarios. So we have here. Again. So we have here our database, Neo4j, then we have our application thing, and then we have our clients working with that. In this scenario, the clients can, or the application basically, can speak any language capable of doing REST. So you're not limited to JVM here. So we have a lot of people using Node.js or Ruby on Rails here or whatever stuff. So for you Java guys, that's not a big concern, but for PHP guys, that is a big concern. So they want to run this server. Neo4j comes with a lot of client drivers. We currently have, I guess, 20-something different drivers for different frameworks or languages. So just pick what you want. So we have Perl, we have even a Haskell driver. There is Erlang, there is .NET. So the whole infrastructure is covered. And if your preferred language is not on this list, you can either write a driver of your own, or you just use the REST API and send cipher statements there to it bare metal. From a scaling perspective, server and embedded are the same. So you can run the clustering on both. So you can run embedded cluster, which means you have your application machines. They spawn up database, and the database internally connect to each other to a replicated graph database. And the same works with server mode as well. Okay, so I have a couple of use cases. I will just briefly go through them. These are from real-world projects. So there is a small company called Cisco in the Bay Area, which does currently 5 projects with us. We have 2 of them here. So one is they had a lot of different systems. They have their knowledge base, they have their ticket system, they have some other information source. And when you have a problem with a Cisco product, you can query them. But there is no unique view on that. So what they did, they created a graph database on top of the existing systems to connect the data. Because they don't want to touch the base systems, because probably they're not flexible to change, probably they're lacking documentation, you don't want to touch a running system, you all know that. So they just create a kind of layer on top of that for a graph. And so if you search for something, you will get results from different sources, and they are connected by the graph, and you can easily see what's around them to get a better support experience with them. That's from the concept a little bit like this Google Knowledge Graph. That was one project with Cisco. The other one, that was in Cisco. It's very complex. So in Cisco, a sales guy sells one of the Cisco boxes. There is a bonus calculation. So he gets some bonus for that. His boss gets some bonus for that. The boss of his boss gets a bonus for that. The country organization gets some bonus for that. The product line organization gets something for that. And that's super complex. A lot of rules and a lot of deviations of the rules in that system. And what they want to have, they want to simulate what price changes would mean to the network. So if we increase the price for product A by 10%, what does that mean? How does that balance out? So that is what Cisco does here. And for that thing, they have already a solution running on the Oracle application cluster, and these kind of calculations, when they change something, took roughly in order of minutes per query, and they're now running on Graph, and they have now a response times of milliseconds. So they can do these queries ad hoc very easily. And if you just want to see how prices changes would affect the network, and you have to wait for minutes, that's annoying because no one can drink that much coffee. Yeah, the next thing, my special project, that was delivered with a small company called Accenture. And they did a logistics project for one of the largest logistics companies in Europe. Unfortunately, due to NDA, I'm not allowed to say the name of the end customer. What I'm allowed to say is that they have a peak of 5 million parcels delivered per day, which goes down to 2,500 parcel route calculations per second. So there is on the parcel, there's a barcode which has the destination address, and it comes to the distribution center. There's a barcode scanner, and through gravity, the parcel goes down a little bit, and then there is the crossroad. You have to go left or right, and from the time from the scanner to the switch, the calculation has to be there. Otherwise, the parcel is going wrong. And that's a pretty bad idea in this Christmas time. We made this project with, I think there were 50 Accenture consultants aboard. So it was a really large-scale, huge project. And they're running here, I think, for the parcel calculation, they're using 6 Neo4j instances. And they configure them. There are 50 people at the end customer sitting and configuring the network, because the trucks travel different routes every day. There's a big customer called Amazon, which has some shortcuts in the logistics network. And they want to reroute and want to optimize the network for low energy consumption or less carbon exposure. So they these 50 people are just optimizing the network. And then they're exporting a snapshot of the network for the next 7 days to the calculation machines. And these are highly tuned machines for reaching that goal. Because a path calculation is complex. It's not just something from one node to another. It's just finding the right way through the whole graph. And even they're down to house number level. So they have, on the lowest level, they have house numbers, then they have streets, then they have parts of cities, their distribution centers, then their super distribution centers. So it's all a huge graph, and they can just configure that very easily. And the data model is also extremely flexible, so they have a kind of meter model stored in the graph. They benefit a lot from the lack of schema that is in the graph database. The next thing, that's Gastor. Yeah, Gastor. Gastor is a small company in the US. It's a job search engine, basically. So rethink the Google thing, right? So Glassdoor was not the first search engine for jobs. So the first generation of job engines was pretty like search engines. So you had your CV typed in Word, you send it to the headhunter puts that to the machine, it's indexed, and if you write in your CV, I don't want to work with Windows anymore, I hate Windows. Well, and then they have a job, we're searching for a Windows engineer. There's Windows in both documents. Well, that is a match. I had this more than once. Yeah, so not the best experience. Then there was the second generation of these job websites where you have to rank your skills. So you can say, okay, well, Java on a scale of 0 to 5, well, probably not 5 or 4. JavaScript, 1, PHP, minus infinity, and stuff like that. So you can just rank yourself, and on the requirement side, they do the same. And then they just match it, do some matrix calculation, and find the ideal candidate for the job. Fair enough, but the ideal candidate is probably busy with some other project. Crap. So what these guys are doing, they put some graph cleverness in that. So you all here in the evening listening to Java talks, so you must be skilled Java developers. And your friends are probably also skilled Java developers. So if you don't want to change the job for that, just look in your Facebook friendships. There's most likely someone like you that might be suitable. So they embed social networks for job search. And these guys are caching roughly more than 50% of the Facebook social graph in the Neo4j instance. And from the number of nodes, that's the biggest commercial customer we have. They're storing, I think, roughly 7-8 billion nodes and more than 10 billion relationships there. So that is huge. And these guys, I think they will have a nice future because they are better than the competitors, like Google was. Yeah, I think we're already running late. So let's just briefly go that SFR is a big telco company in France. And what they do is they have modeled their physical network, the data centers with all the switches, firewall links, blah, 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 to identify single points of failure in the network, and to also do impact analysis. So how will my bandwidth evolve when that component goes down? What is the result of that? So based on the graph technology, they're improving the physical network they have. Somewhat similar is the next small customer we have, HP. They're selling a product to major telco companies. So they have probably a target audience of 50 companies in the world, which means that product is not very cheap. And so they do some management of mobile networks. So think about when there is one of the mobile antennas, the 3G or 4G antenna breaks away, then there's a red flag raised in the system, then a technician needs to get there and fix things up. So if you have just sporadic failures, that's very easy to handle with a loop-based system. But if you have a huge storm going over the country where one antenna goes down, thousands of antennas are broken, and the core components are broken as well, then you need to look at your topology to find the right spots where to start fixing. Because it doesn't make sense if you fix the outer areas of your network when some core component is broken. So you need to focus your forces to do the fixing in the right order. And for that topology mapping, they use Neo4j in that program. Yeah, Telenor, let's go quickly over that. Jumisphere, we skip that. Teachscape, yeah, let's skip that as well. So I'm basically now through with my session. I want to now do some Google, but I think we have some break before. Okay, so let's do a 10-minute break, something like that. I don't have to forget about the price raffle with this at the very last one. Can you read that? Okay. So let's do a little bit of demo. Of course, I could do that for 3 hours and more, but I just give you a little bit of how the thing smells. So it's just scratching the surface. So what I'm doing now, I'm going to install the product. I already downloaded it. So on Windows, there is a nice installer now available. If you're on Linux or Mac, there's a RGZ image as provided. So I just download Neo4j Enterprise. The most recent is 2.00 RC1. And if you want to get started, use that one, please. Okay, so this extracts a nice directory here. And there's well, I don't want to go through details what is here. Important is the bin folder. And in bin, well, there is a Neo4j. Let's see what we can do here. Okay, bin Neo4j. Well, start looks good, right? Let's try to do that. Okay, and it's starting up. And it says here, okay, we're already on localhost 7474. Let's try that. And here we get the Neo4j browser. So that's pretty, if you have used Neo4j 1.9, that looks pretty beauty. So 1.9 was a pretty ugly platform then. We hired another company who did this for us because we know how to make a database, but we ourselves suck at design. So we learned that lesson on. We are perfect at doing software design, but we suck at UI design. Sorry. Okay, so let's look what's in here. So that's a browser problem locally. Yeah, no, it's gonna. So you can explore some stuff, and I need to go fast now. So at first, our database is empty. There is no node, pretty boring. So we need to have populate our database. And for simplicity, we have a movie sample data set, which you can use for exploring how graphs work. So you just have to click here, and then there's some guideline here. Let's make this a little bit larger. So you see here cipher statements: create a matrix movie with title, blah blah blah. So these are statements that build up our graph in cipher code. So you have to click there, and then it's copying that thing here over. And here I can run the graph now. Okay, so it says here that added 169 nodes, 500 something property, 250 relationships. You can explore the code, what that means yourself, I guess. Now let's do a little bit of querying. We have the movie in the database called the matrix. Let's try to find that one. So is that large enough? No, let's zoom a little bit in. Okay. Better? Okay. So we want to match M is a symbolic name. M should be have a label of movie. And the title of that movie should be the matrix. Okay, and what we want to do with that movie? Well, we want to return it. Oh, crap. Return M. Okay. Sorry, the demo code is not with me. Yeah. Chase notation here, so we need to call it.
You're missing the code. Yeah, there is the new code.
The code, yeah, this was, which one was this?
After 30 years.
Yeah. Like that. Okay, thank you for helping me with Cypher. I get back here in the node called the matrix, and we see here the properties of that. And in here we're now here in the tabular result form, but we can also switch to graphic layout. So we have here our node 168, that is the internal node ID. If we click on that node, we'll see here, well, that is the matrix, it has been released. These are the properties on the matrix node. And let's say what's around that thing. Let's click into that. So we have here a producer, we have director, we have another director, we have some actor. Let's look into that guy, 184. And that's Hugo Weaving. You probably know him. We can rearrange that. The problem is the resolution is really crappy, right? But you can do a lot of fun with that to float around here. And you can even change here the layout of that one. Okay, let's say these orange nodes should become, let's say, another color and another size. And you can even change the style sheet for that. By that you can say, okay, I don't want to have the internal ID. I want to have for all movies, I want to have the title property displayed in the visualization. But the graph cannot interfere that without having the knowledge. So you can here export the style sheet, change that, and send it back. And that's basically a little bit of CSS. Okay, but we want to focus a little bit more on the query language. So that was pretty boring, just a single node. We now know we found the matrix, and let's say, okay, who are the actors within the matrix? So we can say, okay, we want to have here then a node called actor, and that is now the two dashes are indicating the relationship. The opening and closing parentheses are indicating the node. So it's like ASCII art. So if you draw that on the whiteboard, you can very easily transpose that to the match clause. But we need to have an incoming direction. Well, incoming looks probably like that. So it's like an arrow. And we need to, as I said, the relationship has a type. We need to filter on the type because if you go back, there are directors, there are producers, there are actors. We're only interested in acted-in relationships. Acted-in. So the actor acted in a movie. Reads like a story, right? Compare that to the usage of primary foreign keys in a join. And we want to return the actor's name. Let's try that. Okay. So, well, pretty familiar list here. Right? There is one error here, so we have here Emil Alfred, which is our CEO, and that's part of the tutorials we have because we need to delete a node, and that's the one we delete. We basically kill the CEO in the tutorial. Okay.